integumentary system is the system that covers the whole body and separates inside the body from outside. First, we'll see the parts of the integumentary system. Then we'll talk about the important functions of this system. Then we'll see the main organ of the integumentary system, which is the skin. So we'll talk about the skin. There are two types of skin present in the body: thick skin and thin skin. We'll see the structure of the thick and thin skin. Okay. Then we'll talk about the glands in your skin. Then we'll talk about the layers of the skin. Skin has two layers. Outer layer is called the epidermis and inner layer is called the dermis. We'll see the structure of the epidermis as well as the structure of the dermis. We'll also talk about a couple other things like water loss through the skin. We'll talk about the color of the skin, those few things. So the parts or organs of the integumentary system. The main organ is the skin, and accessory structures of the integumentary system are hair, glands, nails. So those are accessory structures. Functions. Protection. You know that by separating the body from outside of the body, skin protects the internal body organs. And three ways your skin protects your body, provides protection. Chemical means, physical or mechanical means, and another is biological means. So by those three ways your skin provides protection. First, chemical. Skin secretes low pH mantle. Low pH means acidic, you know that. And that acidic secretion destroys some microorganisms. Okay, acidic secretion destroys some microorganisms. So that is the chemical. Then biological. In your skin you have phagocytic cells. They do phagocytosis. What are the phagocytic cells in the skin? Macrophages and dendritic cells. So they can engulf and destroy the antigens or microorganisms. Physical or mechanical means your skin has two important chemicals, keratin and glycolipids. These two chemicals block most water and water soluble substances. So water cannot enter into the body through the skin, which is good. You know, if when you take shower, like you sometimes sit in bathtub long time and your skin doesn't allow the water and water soluble substances entering into the body, right? Prevents them. Otherwise, what would have happened? lot of water would go in, right? And when it will come out, it will become big, like giant. You don't want that, right? So skin doesn't allow water or water-soluble chemicals, substances. You know that in water you have microorganisms or other harmful things. So those two chemicals of the skin makes the skin waterproof, keratin and glycolipids. Regulation of body temperature, another function of the skin. Your skin has sweat glands, you know that, right? And when the body temperature increases, sweating occurs. Sweat glands release water, and that water takes a lot of heat out from the body, because we know that water has high heat capacity. You have already learned that small amount of water can hold a lot of heat, right? So when water leaves the body, it takes a lot of heat out from the body. So that is one way your skin lowers the body temperature. Another way is when the body temperature increases in the skin, vasodilation occurs in the skin. That means what? In the skin, the blood vessels dilate, so more blood flows in your body surface, because the skin is the body surface. So when vasodilation occurs in the skin, in the body surface, more blood circulates, and from the blood, heat easily gets out through the skin. Because more blood circulates in the skin, so heat can easily leave the body from the blood. So those are the two ways your skin regulates or lowers the body temperature. Number one I have mentioned, sweating, and number two, vasodilation. Cutaneous sensations. Your skin has receptors. Those are called cutaneous receptors. Cutaneous means skin. What are the cutaneous receptors present in the skin? Pain receptors, touch receptors, temperature receptors. So pain, touch, temperature, those receptors are the cutaneous receptors. And because of the presence of those receptors, you feel those sensations. If someone touches your skin, you feel that, right? If something touches your skin, you feel that, because you have touch receptors. If something bites you, you feel pain, because you have pain receptors, right? If something hot or cold touches your skin, you can discriminate that, you can tell. So the cutaneous receptors protect our body. How? Just think that if something very hot touches your skin, you immediately, right, without looking, you can tell, and you can move the body away from that. So those cutaneous sensations are very important for our survival. Metabolic functions. Your skin produces the precursor of vitamin D. When the sunlight falls on the skin, with the help of sun, your skin produces a chemical that is called cholecalciferol. This is an inactive vitamin D. It's a precursor of vitamin D, and skin produces it. Okay, then it is taken to the kidneys, goes to the kidneys, and inside the kidney, the cholecalciferol is converted to calcitrol, which is the active form of vitamin D. Calcitrol is the active vitamin D. Okay, so you see, skin produces the precursor of vitamin D with the help of sunlight. So this is another important function of your skin. Excretion. Through the skin, some metabolic toxic chemicals are excreted. Okay? Through the skin, some nitrogenous wastes or metabolic wastes and salts are leaving from the body. So those are the important functions of your integumentary system. Now, skin. There are two types of skin in your body, as I have already mentioned, thick skin and thin skin. Both thick and thin skin have two layers. Outer layer is called the epidermis and inner layer is the dermis. So dermis and epidermis. Okay. So outer epidermis, inner is the dermis. Now, epidermis has 4 or 5 layers. So first, the skin has 2 layers, outer epidermis, inner dermis. Then epidermis has 4 or 5 layers. Why 4 or 5? Because in thin skin epidermis you have 4 layers. In thick skin epidermis you have 5 layers. That is the difference. Okay. So in thin skin epidermis you have 1 layer missing or less. Okay. Although dermis is much thicker than the epidermis, but dermis has only 2 layers. Only 2 layers. Okay. So epidermis has 4 or 5 depending on if it is thick or thin skin, and dermis has 2 layers. Both in thick and thin, dermis has 2 layers. Okay. Now under the dermis there is another layer which is not a layer of the skin. Under the dermis there is another layer, but it is not considered as a layer of the skin. This is called hypo. Hypo means below dermis, below the dermis. But remember, this is not a layer of the skin. Skin has only 2 layers, outer epidermis, inner dermis. Okay? Hypodermis contains a lot of fats or adipose tissue, okay, filled with fats or adipose tissue. This is also called subcutaneous layer. Subcutaneous layer under the skin, and this is a good site for injection. Subcutaneous injection, probably you have heard. Thin needles are used to inject the drug just under the skin, right? Like insulin, just under the skin. Why we inject drug in subcutaneous layer, in hypodermis, where you have a lot of fats? When you inject the drug in this layer, fat has less blood flow. Remember, fat tissue has less blood flow in it. So the drug will stay there for a long time and will slowly enter into the blood because less blood goes to the hypodermis. Okay, and the drug will work for a long time. So those drugs we want to work for a longer time, like insulin, we inject in hypodermis. So slowly it will enter into the blood. Okay. Important structures found in the skin. in your skin, you have some structures, glands, two types of glands, sweat and sebaceous glands. Sweat glands are responsible for thermoregulation, regulation of body temperature that I have already explained to you. Sebaceous glands secrete oily secretion, and this secretion, oily secretion, keeps the skin and hair soft and oily. Soft, smooth and oily. Anyway, so those are two types of glands present in the skin. In the skin, you have hair follicles and hair roots. You will find cutaneous receptors that I have already mentioned. Pain receptors, touch receptors, temperature receptors, and those are located at the free nerve endings and corpuscles. So those receptors are located, pain, touch, temperature, those receptors are located on the free nerve endings and inside the corpuscles. In the skin, you have blood vessels and tiny muscles. Those are called erector pili muscles or erector pili muscles. These tiny muscles cause goosebump. You know, when you get scared, hair erect, right? So erection of the hair, goosebump. Now, skin has blood vessels only in the dermis, in this layer, inner layer. Epidermis is avascular, no blood vessels in the epidermis. So the blood vessels of the skin are only present in the inner layer, dermis. Here in the epidermis, you have no blood vessels. Now the question is, then how the epidermis gets blood, nutrition and oxygen? From the underlying dermis by diffusion. From the dermis by diffusion, nutrition and oxygen enter into the epidermis. Okay. Oxygen and nutrients enter into the epidermis, but epidermis doesn't have blood vessels. It's avascular. Okay. The epidermis has different types of cells. So in this layer, you will find different types of cells. Most of the cells are squamous. You know that squamous epithelial cells you have already studied, right? Those are flat cells. So in the epidermis, most of the cells are what? Squamous type of cells, like flat cells. They form many layers. That's why we say stratified squamous. You already know, right? Stratified means many layers. Squamous, flat. So many layers of flat cells. Many of these cells are dead cells because you know that epidermis doesn't have blood circulation. It gets nutrition and oxygen from underlying dermis by diffusion. So those cells are located in the deeper part, inner part. They are mostly alive because they get more nutrition and oxygen. As you go towards the surface, these many cells are dead squamous cells. Okay? So that is the main type of cells, squamous. Other cells in the epidermis are keratinocytes, melanocytes, dendritic cells, also called Langerhans cells, and tactile or Merkel cells. So those are other cells in the epidermis. Okay? Here you see the structure of the skin. outer epidermis, inner dermis, and under the dermis, hypodermis, contains a lot of fat. You see the yellow structure, those are fat globules. Now, here you see one thing, most of the skin structures are located in the dermis, that means in the inner layer, which is very thick. So this whole part is the dermis, this is the epidermis, and you see most of the skin structures like erectophilae, muscles, glands, so it's sebaceous glands, hair root, hair follicles, corpuscles, free nerve endings, blood vessels, all those structures are present in the dermis. Epidermis has only the cells, mostly stratified squamous cells. Okay. Now, we will talk about the epidermis, the outer layer. You know that it has 4 or 5 layers. In thin skin you have 4, thick skin you have 5. So what are those layers in the epidermis? We'll see that, okay? What are those layers? If you start from the inner part of the epidermis, innermost layer is the stratum basal. Stratum basal or basal layer, deepest layer of the epidermis. And this layer has a single row of stem cells. So, a single row of stem cells are present in this layer, stratum basal. And you know that stem cells quickly multiply to produce new cells. So, these cells are here, they are producing new cells. Because we know that many outer cells are dead, so those cells will shed, will get out, and new cells will start to move up. And for a new cell to reach to the outermost layer from the stem cell, it takes 25 to 45 days to reach from here to here. So outer cells are dying and getting detached, and new cells are moving up. Okay. Then next layer is stratum spinosum, which is also called prickly layer. Why this layer is called spinosum? Because the cells, if you see the cells, have many spines, spine-like processes. Okay, so that's why this is called spinosum, many spiky processes. And this layer contains the chemicals, melanin, important chemicals that give the color of the skin. You know that melanin gives the color, right? Dark color of the skin. So, melanin granules are abundant in this layer, and also you have dendritic cells. You remember I said phagocytic cells of the skin, macrophages and dendritic cells. So the dendritic cells are also located in this layer. Dendritic cells do phagocytosis, biological protection. Then next layer is stratum granulosum. Why this layer is called granulosum? Also simple. The reason is, in this layer the cells are filled with granules. Cells are filled with granules, highly concentrated chemical granules. Okay, that's why this is called granulosum. Which granules are present inside the cells in granulosum? Keratohyalin and lamellated granules. Those are the names of those granules you need to remember. Okay, keratohyalin and lamellated granules. These granules mostly make the skin waterproof. You know that skin is waterproofness. Next layer is stratum lucidum. This layer is also called clear layer. Why? Because this layer is transparent like a glass, thin layer of glass. That's why this is called lucidum or clear layer. And this layer is only present in the thick skin, because you know that thick skin has 5 layers, thin skin has 4 layers. So this one is missing in the thin skin, only present in the thick skin. Okay. So if I ask you in the test which layer is missing in the thin skin, this is the layer. And outermost layer is the stratum corneum. So outermost layer is the stratum corneum, and remember this layer gives the thickness of the thick skin. Stratum corneum is responsible for the thickness of the thick skin. In thick skin, this layer is very thick, stratified squamous, many layers of flat cells, squamous cells in thick skin. So it is very thick, that gives the thickness. And in thin skin, this layer is much thinner. Okay, so many cells are dead cells, dead squamous cells, and in this layer, the cells are also filled with those two chemicals. You remember at the beginning I said that keratin and glycolipids. So those give the waterproofness too. So keratin is a protein. Keratin is a highly specialized protein. Specialized protein. Okay. Fill the dead squamous cells in this layer. So all these cells are heavily filled with keratin, and this keratin specialized protein makes the waterproofness in the outer layer of the epidermis. Okay. So those are the layers and some important information about those layers of the epidermis. Now if you see the thick and thin skin side by side, you can see that in thick skin you have lucidum, that clear layer. In thin skin you don't have that layer. Okay? So that is one difference. In thick skin you have a stratum lucidum, clear layer. In thin skin you don't. Another important difference is, you see, in thick skin stratum corneum is very thick, many layers of squamous cells. In thin skin the corneum is much thinner. Okay? Here you see the layers that I have explained, so you can now go over. Keratinization. Keratinization is a process. How these dead squamous cells get filled with keratin. You remember I said that the squamous cells, dead squamous cells in stratum corneum get filled with keratin, highly specialized protein. So keratinization is the process how these cells get filled with keratin. So keratinization. Now, what happens? There are two types of cells in the epidermis. one type of cells. Those are called keratinocytes. Keratinocytes. These keratinocytes do what? Produce and secrete keratin. So, keratinocytes produce and secrete keratin. Okay? Keratinocytes. Keratin producing cells. Cytes means cells. Keratin producing cells. So, the keratin is produced and secreted by these cells. Then, what happens? You have dead squamous cells. These are flat squamous cells. The keratin molecules enter into these dead squamous cells. So these cells get filled with keratin. This process is called keratinization. The keratin molecules enter into the dead squamous cells. Okay, so this is keratinization, and now these cells are called keratinized cells. Okay, so two types of cells you see here. Keratinocytes produce and secrete keratin, and keratinized cells are dead squamous cells get filled with keratin. Okay, so remember that the difference is there. Okay. Now we'll talk about the dermis, the inner layer of the skin, which is very thick, and most of the skin structures are present in the dermis that I have shown you. Now, dermis has two layers. Although it is very thick, it has only two layers that I have mentioned already. Two layers. The outer layer is called the papillary layer, which forms about 20% thickness, and inner layer is the reticular layer. Reticular. So outer papillary layer and inner reticular layer. Those are two layers of the dermis. Okay. Here you see the dermis in the left side, papillary layer, which forms 20% thickness of the dermis, and reticular layer forms about 80% thickness of the dermis. Okay. So those are two layers. Now you need to know what kind of tissue forms those two layers. Papillary layer is formed by loose areolar. You already know loose areolar tissue, connective tissue, right? Areolar type connective tissue. So it is soft, loose. And reticular layer is formed by dense, irregular. You already know about those two types of connective tissue. Dense, irregular type of connective tissue. So dense means what? Fibers are heavily packed, right? Dense. And loose is few fibers are present, loosely. So this layer is soft because this is loose, areolar. This layer, reticular layer, is very hard, strong because it is dense, irregular type of connective tissue. Okay. Dermatitis is the inflammation of the dermis. Itis is the inflammation, you know, right? So dermatitis is what? Inflammation of the dermis of the skin. Now, when inflammation of the dermis occurs, the outer layer That means the papillary layer is affected most of the time. The reason is, you already know, papillary layer is loose areola, right? So the tissue is soft. Make sense? Loose areola, tissue is soft. So the soft tissue get injured easily. You know, microorganisms can easily penetrate into soft tissue, can spread inside the soft tissue. But in dense tissue, inflammation doesn't occur easily because it is very strong, right? Dense. So microorganisms cannot easily penetrate into the reticular layer. Or mechanical injury also occurs more in papillary because that layer is soft. You know, so when injury occurs due to scratch or pressure, that will cause inflammation in the papillary layer. Usually not in the dense layer, reticular layer, because it is heavily packed by fibers. Water loss through the skin. We'll talk about the water loss from the body. From the body, we lose water in different ways. Most of the water gets out through the urine. You know that, right? Most of the water gets out through the urine. Anyway, through the skin, we also lose water. We lose the water through the skin in two ways: sensible and insensible. When sweating occurs, you tell me, you know, when sweating occurs, what do you think? Is it sensible or insensible? Do you see it or not? Sweating. You see it, right? So you feel it. So it is sensible. Water loss, sweating. Also, through the skin, we lose water by evaporation. 24 hours, all the time. You don't see that. When even you are in resting or sleeping condition, through the skin, water molecules are leaving the body. That one you don't see, you don't feel, because that occurs by evaporation, and that is insensible water loss. So through the skin, we lose water, both sensible, which is sweating, and insensible, which is evaporation. Okay. Color of the skin. Your skin has melanin. Melanocytes are the cells in the epidermis that produce the chemical called melanin, and that is the main pigment that is responsible for the skin color. Melanin is the main pigment that is responsible for the color of your skin. And you see, some people are black, white, brown, yellow, different skin color, right? Which is interesting, and mostly given by the melanin. In dark skin, more melanocytes are present. Melanin producing cells are more. Melanocytes produce melanin. And melanin is dark to brown colored pigment. Brown to black or dark pigments. So if someone has more melanocytes, more melanin will be produced. Make sense? So the color of the skin will be dark. If someone has lack of melanin, the color will be less dark. So that is the main chemical. Now, melanin is important because melanin forms a protecting layer which is called the shield, melanin shield, that prevents the UV radiation from entering into the deeper part of the skin. So melanin forms a protecting shield or layer that does what? Stops what? UV, right? Radiation. So those people who have dark colored skin, their skin is more protected against the UV radiation. Make sense? So has less chance of skin carcinoma, because you know that radiation can cause carcinoma. So they are more protected against UV. Other chemicals or pigments, those are responsible for the skin color, are carotene, which is yellow to orange colored pigments. And in human, we have very small amount of carotene, particularly in the palm and sole. In those areas, we have small amount of carotene. In some fruits or vegetables, you have plenty of carotene. Example, carrot. What's the color of the carrot? Orange, right? Is heavily filled with carotene. The skin of the oranges, you have plenty of carotene. But in human, we have trace amount, small amount, particularly in the palms and soles. Hemoglobin. You know that hemoglobin is red colored pigment. Red colored pigment inside the red blood cells. And because of hemoglobin, your blood color is red. Because of what? Hemoglobin. Your blood color is red. Make sense? If in the skin more red blood cells circulates, that means more hemoglobin is circulating there, right? The color of the skin will be reddish. If someone has less hemoglobin in the blood, the skin color will be what? Pale. Make sense? In anemia, you know that the color of the skin gets pale because less hemoglobin. We know that the skin has blood circulation. So the hemoglobin also contributes to the skin color. If someone has more hemoglobin, the color will be kind of reddish, pink, less pale. Some clinical conditions can be detected or diagnosed by looking at the skin color. So, skin color can help you to diagnose some clinical conditions. Example, anemia that I have just mentioned, right? If someone has less hemoglobin, the color of the skin will be pale. So if you see that, you can suspect that the person might have anemia. Hypertension, more blood flows. Blood pressure is high in hypertension, right? So more blood flows in the skin, particularly when more blood flows in your face, skin of the face looks flashing face. So by looking at that, you can tell that person might have hypertension. Jaundice. Jaundice is the yellow coloration of the skin. So if you see someone's skin is turning to yellow, the color is turning to yellow, you can suspect that might be jaundice. Now, why the color of the skin gets yellow in jaundice? Due to bilirubin. Bilirubin is the pigment that is produced due to excessive breakdown of red blood cells. So, if the red blood cells are destroyed more, then the hemoglobin comes out and is converted to bilirubin. So, basically hemoglobin, which is red pigment, is converted to yellow colored pigment bilirubin when it comes out from the red blood cells due to breakdown of the red blood cells. Cyanosis is the bluish coloration of the skin. If someone has lack of oxygen in the tissue, then the color of the skin turns bluish. So that is cyanosis. So those can be easily detected by looking at the color of the skin. Okay, now we'll see the glands of the skin. Skin has two types of glands that I have already mentioned. Remember, all skin glands are exocrine. So skin glands are exocrine type glands. You have sweat glands, sebaceous glands in the skin, both are exocrine type glands. And the exocrine glands of our body are divided into three types of exocrine glands. We are not talking about skin glands here. Just know that skin glands, all skin glands are exocrine type glands. Now I am talking about the types of exocrine glands. We divide the exocrine glands of our body into three types based on the mode of secretion, how they secrete the chemicals. Based on that, we divide the exocrine glands into merocrine, apocrine, and holocrine. Okay. So what is the difference between those three? In merocrine, what happens? This is the gland, and inside the gland you have the cells. So these are the cells inside the gland. Okay. And in merocrine type secretion, what happens? First, inside the cell, the vesicles are formed. So these are the vesicles. You know that membranous sacs, and chemicals accumulate inside the vesicles. These are vesicles get filled with the chemicals. Then what happens? These vesicles move towards the free end, apical end. So all these vesicles will come here. They are filled with what? Chemicals. And next what will happen? These vesicles will rupture. Lysis of the vesicles will occur and the chemicals will get out. This process is called exocytosis. Lysis of the vesicles. Exocytosis. So the chemicals are released to the outside. So this process is called exocytosis, and this mechanism is merocrine. Secretion occurs in merocrine type of glands, exocrine glands. Okay, then we'll see the apocrine type of secretion. What happens in apocrine type of secretion? No vesicles are formed. The chemicals are produced inside the cells, and then what happens? The chemicals start to move to the upper end. So most of the chemicals accumulate at the upper end or apical end here. So in all these cells, the chemicals go to the upper end, and then what happens? The entire upper portion of the cells are destroyed. So what happens? The chemicals get out. So entire upper portion of the cell membrane is destroyed. Lower part remains there, like this. Okay. So the chemicals are now out, and this is called apocrine secretion occurs in apocrine gland. And then what happens from the bottom part, since the bottom part is still there, again the top part is formed. Top part is formed again. Again the chemicals accumulate there and entire top part is destroyed again. Okay, again new top part is formed. So that's how the apocrine glands secrete the chemicals. The last one, holocrine. Holocrine type of secretion occurs due to the complete destruction of the cells. So what happens? These cells are filled with chemicals everywhere, and when the secretion occurs, what happens? The cells are completely destroyed. Completely destroyed. So the chemicals are out. This is holocrine. Probably you have heard the term holocast. Very often we hear killing, right? Killing. Holocast. Have you heard this word? Killing. So the secretion occurs by the complete death of the cells, killing of the cells. So what should happen then? How the gland will get new cells? Inside the gland you have a lot of stem cells. So from these stem cells new cells will be produced. So completely new cells must be produced because the cells are completely destroyed during the secretion. Okay, so those are different types of exocrine glands based on the type of secretion: merocrine secretion, apocrine secretion, holocrine secretion. Okay, now why we need to know this? Because the skin glands belong to all these three types. That means your skin glands secrete the chemicals by all these three means. So skin glands are sweat glands and sebaceous glands. You know that already. There are two types of sweat glands. One type of sweat glands do merocrine type of secretion. This type. See the merocrine sweat gland. Another type of sweat glands do apocrine secretion. So they secrete the sweat in two different ways: acrine or merocrine sweat glands and apocrine sweat glands. Those are two types of sweat glands because the mode of secretion is different. Now merocrine sweat glands are abundant on palms, soles and forehead, in those areas, and this secretion is highly watery. 99% is water, so very watery secretion. Small amount of sodium chloride, salt. You know, if you taste the sweat, if you touch your tongue on the skin when sweating occurs, you taste salty because sodium chloride is the salt. You know that. Vitamin C, antibodies, metabolic wastes. So the sweat is not only salty but also weird taste because of metabolic waste present there. Ducts connect to the pores. So from the acrine sweat gland, you will see a duct arises. Acrine sweat gland is like a coiled tube, and from there a duct goes to the skin surface. This is the pore. This is the duct tube. This is the gland. Okay? The skin surface. So from the gland, the secretion gets out through the duct and releases to the outside of the skin, surface of the skin through the pore. So it comes out. Okay. Function is thermoregulation, regulation of body temperature, because you know that when sweating occurs, the water gets out, and that water takes a lot of heat out from the body. Water is has high heat capacity, you know, that can hold a lot of heat. Apocrine sweat glands are confined to the axillary and anogenital areas around the genital organs and anus, and in axillary armpit area. And this type of sweat glands secrete oily secretion, oily substances, and the function is this secretion has the chemicals that can destroy the microorganisms. You know that in those confined areas, the chance of microorganisms, growth of microorganisms is more in axillary or in those closed areas. So this secretion contains the chemicals that can destroy the microorganisms. Sebaceous glands are also called oil glands, widely distributed in the body and mostly develops from the hair follicles. That's why you see the sebaceous glands are attached to the hair follicles. You see here, this is the sweat gland, eccrine sweat gland, coiled tube, duct and pore that I have shown you here. But if you see the sebaceous glands, these are sebaceous glands attached to the hair follicle. This is the hair follicle, because they grow from the hair follicles, okay, and secrete oily secretion. The sebaceous glands become active at puberty. So become active at puberty, and the secretion is called sebum. The chemical that is secreted, oily chemical, that is called sebum. And the secretion occurs by holocrine. You remember holocrine, the whole cell is destroyed, so new cells must be produced from the stem cells. So this is the type, the mechanism how the secretion occurs in sebaceous glands. And the action of sebum is bactericidal, killing the bacteria. Also, another function I mentioned at the beginning of my talk today, softening hair and skin, makes the skin soft and oily, smooth. Okay, so here this is the histology under the microscope. You see this is the hair follicle here, and this is the sebaceous gland attached to the hair follicle, right? This is the hair follicle, these are sebaceous glands. Now you see inside the gland, these are the cells. They are completely destroyed to release the chemicals from them. And these are the stem cells. You see here carefully, these tiny cells, these are the stem cells. They produce new cells. Again, they are destroyed completely and new cells are produced from the stem cells. Okay, so holocrine type secretion. So you see two types of sweat glands secrete the chemicals in two different ways, eccrine or merocrine and apocrine. And sebaceous secretion occurs by holocrine type secretion, right? So that's why you needed to know all these three types of secretion, how they occur. Okay, make sense? Okay, let's stop here today.